Hello, students. My name is Ross Teixeira.
And I'm Gilbert.
We're your TAs for 61B this fall, and we're coming to you from sunny Soda Hall to give you an intro to your first project, Project Zero, Canfield Solitaire.
So before you watch the rest of this video, make sure you've looked at the code that we provided and read through the spec, especially.
And it got too hot outside, so we have moved indoors. So the first thing I want to introduce you to is the text interface for the project. So first, here I am in my Project Zero directory, and to run the project, I type java canfield.main and --text. So this is the text representation of Canfield. So just like this picture here, we have 4 Tableau piles, as you see here, and then we have 4 foundation piles up here, and then the reserve, the stock, and the waste are these 3 things here. Now currently everything on the stock is face down and there's nothing in waste. If I were to type C, then I would move some cards from the top of stock into our waste, and you'll see that's what's happened here. Now I have this Jack of Clubs here in my Tableau that I can move to the foundation. So how do I do that? Well, I don't remember the command, but I can type H or help to get a list of all the commands in the game. So let's see. Move card from Tableau T to foundation. All right, this sounds like it. So just have to type TABFND, and this is 4. Cool. So the Jack moved up to the foundation. So the first part of the project that you will be coding is the undo feature. So you should be able to type undo and revert the game back to the previous game state. And you should be able to do this all the way up until the very first, before anything has before you've made any moves in this project. So for instance, I can type undo right now, and the Jack should come back into the 4th Tableau pile. And you'll see that it has done that. Cool. And I should also be able to undo my moving cards from the stock to the waste. So if I undo that, you see, now the waste is empty, and we're back at the state when the game first began. So this text-based interface is nice and all, but wouldn't it be great if we could actually see these cards on our screen and be able to move them around? Well, that is the second half of the project, where your job is to create a graphical user interface for Canfield Solitaire. Now, how do we run this? Well, we can run java canfield.main and just leave off the --text. So if I do this, let me show you how we've designed it. So this is Canfield Solitaire, written in Java as a GUI. So we have all the same locations in the game. The Tableau is down here, the foundation's up here, your reserve, your stock, and your waste. But they are now represented as actual cards rather than just text. And I can click and drag things around in this box and actually play the game. So let me show you how that works. I can click on the stock here to deal some cards into the waste. Now I can't do anything with this 3 or that 3, so I can look through all the cards, but I see that this Jack here I could move into the foundation just like last time. So to do that, we have it where you can just click and drag and then let go, and the Jack will move up, and we see the next card on that Tableau. Now we also have a little menu up here with a few options. It allows you to undo the game to a previous state. So I can go back to the Jack being in the Tableau. I can also start a new game from scratch and reshuffle all the cards, or I can quit. Now, how might you go about actually implementing something like this? Well, that's really the goal of the rest of this video. I'm going to try and give you a sense of how to approach this project and what things to keep in mind as you're looking through the code, and then where to start writing your own GUI. So the first thing we run when we start the project is canfield.main. So that's probably a pretty good place to start. Now I'm going to open up my IDE. I'm using IntelliJ, and here is the main class of the project. So this main function gets run whenever we first start up the project. Now, it looks like it's doing some checking of our command line arguments. We can pass in text, or we can pass in a seed for the random number generator. And then we call main.run. Now, if we go down here, run sets up a new game object. Now, so game is really the main class that's going to be holding all of the state of the game. And it gets updated whenever you make a move and things like that. And we also have a player. Now, down here, there is an if case where if our command line contains dash dash text, it's going to set player equal to a new text player. If not, it's going to set a player equal to a new GUI player. And then down here, it calls player.play. So either we're using a text or a GUI player. So what actually is a player? Well, player here is an abstract class. And as you know, abstract classes cannot actually be instantiated, but they can have subclasses. And they also define certain functionality that every class that extends a player must have. So for instance, we have this abstract void play method, which actually plays a game of solitaire. Now, every player object has to have its own implementation of this play. And that implementation differs greatly whether you are using the command line or using the GUI. So for instance, in text player, we have this big function here, play, that is looks like it's checking command line commands from the user and then calling the proper functions in game. What about the GUI? So we have GUI player, and all play does is it calls new Canfield GUI. So it creates a new Canfield GUI, and then somehow the GUI just pops up and you can start playing the game. So how does that work? Well, I'm going to segue a bit into talking about the sample GUI that we've given to you, and then I'll show you how it applies to the Canfield project. So graphics, how does it work? So if you go back into your project directory and you run java GUI.main, you'll be greeted with this interface, which is a little sample graphical interface that we've given you that consists of just points and lines that connect them. So for instance, if you click around, you can generate a few points, and I can also click on a point to create a line, and then I can also click and drag each point around, and the line moves along with the point. And you can connect these in any shape or formation you'd like. I think I'll make a little arrow out of mine. So now let's talk about what's actually going on in the inside. So these are the Java files that make up the GUI you just saw. There are the point and segment classes, and these represent each individual point as well as each individual line that connects those points. So these are the basic building blocks of the data in the interface. Then we have three classes here. We have data display, sample data, and sampled GUI that actually do the work of running the interface. Now, I made a little chart here to show you how all these files work together. So the graphical interface we've given you in the sample and in Canfield as well embrace a software design pattern called Model View Controller, where the work is divided up into three sections. Essentially, let me move myself out of the way so you can see this. So this is us. We are the user, and we want to make some change to the interface, maybe by adding a point or adding a line. So we perform an action by clicking on the interface. And the first thing that happens is the controller, our sample GUI, is notified that we have clicked on the interface. Now the job of the controller is really to accept input from the user and then make those changes happen to the data, and then tell the actual visuals to update so that the user sees what's going on. So when we click to create a new point, we're updating the underlying data based on our click. And so sample data, which is the model, represents all of the data in the interface, the collection of lines and points. So when we click, we make a new point, and the controller tells the model, here, make a new point and store it. Then it also goes and tells data display, which is the view. And this is what actually draws the points and lines on your screen. It tells the view to go ahead and refresh because we've added a new point. And so it redraws everything. And finally, that output is displayed back to the user. And you see that a point has been drawn. So this is our main class for the GUI. And just like before, there's a main method that creates a new sample GUI object. Now this is our controller. So let's actually go look at that controller. What happens when it gets created? So there's a lot of code here, and I'm going to talk about it in more detail. First thing is we create some buttons here. So let me go back to the interface here. You'll notice that we have a data tab on top, which we can click on, and then there's a little drop-down menu with two options, clear and quit. So those clear and quit buttons are actually added by these functions here. We make a call to add menu button with this syntax, where data is the tab, and then we put a little arrow followed by clear. And then we put the word clear, and I'll explain what that means in a second. But let's say I wanted to add a new button called greet, which when you click on it, prints a little hello message to the user. So I can create a call to add menu button here, and I'll put it in a new tab, miscellaneous, call it greet, and then give it a name, greet. Cool. So now if I were to run the GUI again, you'll see it pop up here. Ooh, we have a problem. Method not found. So I actually can't run it yet. So this would be a good time to explain what this name is for. So when you click on one of these buttons in the interface, it's going to take this name and it's actually going to call the name of a function called greet. So for instance, the button clear down here calls a function called clear. So we have a function clear that clears all of our data and then tells our view to repaint and to get rid of the old points. So if we're going to make this greet button work, we need to create a new function called greet. So public void greet. And we have to pass in a string. That's not important for this project. And then with this, I'll just have it print hello. Okay, so now if we run the GUI, things should actually work properly. Yeah, so we have a new miscellaneous tab here at the top. And if I click on it, there's a greet button. Let's try that. And the command printed hello. So that is how you add buttons to your interface. And I'll go ahead and click quit. Oh, and it asked me, do you really want to quit? So that is happening in this function here, quit. We have a show options command, which takes in some text and then some possible choices, and based on that, it might exit out of the program. Now there's a lot of these functions that you can use in your controller to work with, and they can all be found inside the library, inside our UCB graphics library. So for instance, if we go into the UCB package docs, we will see some classes here. Right now I'm in the class top level, and that's because sample GUI extends top level. So you can think of top level as representing our controller for this project. And in top level, we have many functions, like add button, for instance, but also more interesting ones that might let you set other options or ask the user for input. Now, there are many more things we have open to change here. First, I see a width and a height here that's set to 300 by 300. Now, these numbers are numbers of pixels on your screen. So, for instance, I could double these to 600 by 600. And if I rerun the GUI, it should create a window that's twice as large on my screen. Yep, so now we have plenty of more room to draw points. Let's get out of that. Now let me show you about these functions down here. We have mouse clicked, we have mouse dragged, mouse released, and mouse moved. So these are special functions that get triggered in the graphical interface whenever its name happens. Whenever the mouse, for instance, gets clicked or moves around or drags something with it. So let me show you how that works. Here's the function mouse moved, which says action in response to a mouse moving event. So I'm going to add a print statement here just to see how often it actually calls this function if we move the mouse. So now I will run the GUI. Hey, and whoa! You can see a bunch of messages flying by every time I'm moving the mouse, even if I just barely move it. So what's going on here is that every time I move the mouse by any pixel amount, it's going to call the event mouse moved. So this happens very, very rapidly, and that's great, but this doesn't really tell us much information about what the mouse is actually doing. So what if we could get, say, the coordinates of where the mouse currently is on our interface? Now, the function takes in this mouse event object. So let's go look at the library for mouse event. We have some functions here, get x and get y, which return the horizontal and vertical position of the mouse. So this sounds like it'd be useful. So I'm going to update our print statement to instead give us the x and the y coordinates of our mouse. And now if I run the GUI, you'll see that now, instead of just getting moved, I get the exact location of the mouse in terms of pixels in our giant interface here. So in the project, say, if you have a card in a certain location and you want to click just that specific card, it would probably be helpful to know where the mouse actually is, to know whether we're clicking on that card or not. So using mouse events is a helpful way to do that. So this is mostly how our controller is going to work. You can set up some buttons, and you can also set up some events for whether the mouse clicks or moves around the screen. And based on that, we can manipulate our model. So let's talk about the model next. In the sample GUI, our model is sample data. And sample data simply stores a set of points and a set of lines that connect them. So back in our controller, whenever we clicked in the interface, we created a new point, right? So in this event, when the mouse is clicked, it's going to check whether or not there is already a point at that position. And if there isn't, then we call data.addPoint. So addPoint is a function that generates a new point and then stores it inside our model. Now, the last step is actually getting the new points and the lines to display on the interface. And that all happens inside the view. In this case, the view is represented by our data display class. So let me talk just for a sec on how displays work when you're writing the code. Now, when I was moving the mouse around before, everything is represented in pixels. And that is exactly how views work when you want to draw an interface in Java. What you do is specify the coordinates of what you'd like to draw, and that gets just put onto the screen exactly where you want it to go. So, for instance, let's look at, so first, actually, let me go back to the controller. So again, this is the mouse clicked function. When we clicked, it will create a new point and or line. And at the end of this function, it calls display.repaint. So repaint is an important function. Repaint tells the view that we have actually made a change to the underlying model. And it signals the view to go ahead and redraw everything, to update itself. And we call repaint in every one of these functions, in mouse dragged, in mouse moved. So repainting is very important in your controller. Now, when you call repaint inside the view, the function that actually gets called is paint component. So paint component is the key function that actually redraws everything in the interface. So for instance, let's look at what's happening here. First, we set a background color, and then we specify a width and a height, and we call fill rect. Now, fill rect stands for fill rectangle, and this call is going to draw the background of the whole interface. And then after we've drawn the background, we will start drawing lines, and then we'll start drawing points. So when you draw things in an interface, every new object that you draw is drawn on top of the previous thing you've drawn. So that's why we start with drawing the background first, and then we draw the lines and points on top of it so that they'll actually show up. And this is what's happening every time you call paint component. It's going. And I just ran out of recording space, but we are back now. And just to reiterate, paint component gets called whenever the view needs to redraw everything to the user. And it does so by calling functions on a graphics 2D object G. Graphics 2D has many other functions that you can use, and you can also find them by checking out the graphics 2D library that's linked in the spec. Now, meanwhile, I have gone and updated the picture from before with the methods that you'll actually use, the relevant code for each of these steps. So when the user performs an action, it invokes the mouse clicked or mouse dragged functions, and those are picked up by the controller. Then the controller is going to update or perform some action on the model in some way, and I'll talk about that in a second. And after that, it then tells the view that it needs to update itself and redraw everything. And you do that by calling .repaint on the display object. And finally, the view redraws everything to the user by calling functions like fill rect and draw image and other functions that will actually make things show up on the screen. Now, in the sample GUI, our data was just points and lines. But this structure is actually very, very relevant to the Canfield project itself and the Canfield GUI. All of these functions are the exact same functions you'll be using inside the Canfield GUI. In fact, the only real difference is what the underlying data is. Now, in Canfield, we represent the game state by using a game object. And there are also pile objects and card objects. Now, each of these classes make up the model of the Canfield game. And so this really forms the complete structure of how the GUI works in Canfield. So by following this, hopefully it will make a bit more sense how all of the graphics functions work together, and then you can get on your way to making your own GUI. Oh, and I forgot to mention actually what these classes are called. So in Canfield, the sample GUI is instead called the Canfield GUI, and that is our controller. And then the model, of course, is represented by game, pile, and card. And then the view here is represented by a class called display. And we should see that in the, oh, no, it's called game display. So there is game display in Canfield, and that represents our view. So this, again, is the complete picture of the Canfield GUI, and hopefully you're ready to get started. So thanks for watching. If you have any comments, you can post them in our Piazza post, and in addition, any YouTube comments below we'll be reading and answering in a follow-up video. So thanks for watching, and good luck!